Hello everyone. So today we're going to continue on 13.2. So our last video we get to look at how do we calculate matrix exponential using eigenvalue and eigenvector. As it turned out, it was just using one of the formula that we have already learned from 13.1, which is this formula right here, u lambda sub t u inverse. So today what I want to do is go for another example on finding matrix exponential and try to use that to solve a system of differential equation, or actually maybe this one would just well, actually, we could, but let's go for the same thing first. We're going to try to find a matrix exponential first, and then we're going to try to use it to solve a initial value problem. So let's see. Okay, so let's try this one. So this one will be a little harder because it's going to be a complex eigenvalue with complex eigenvector. All right, so let's see. Let a equal to 5, -4, 2, 1. Let's find the eigenvector and eigenvalues for matrix A first. Okay, so as I already told you, this one would be complex eigenvalue eigenvector. So let's go for it. So I'm going to do this. So determinant of A minus lambda I equal to 0. So therefore become 5 minus lambda times 1 minus lambda minus 2 times -4 equal to 0. So that would be 5 minus 1, so minus 6 lambda plus lambda square minus 8, minus -8, so we're in plus 8 equal to 0. So that come out to be lambda square minus 6 lambda plus 13 equal to 0. So you can easily find the complex root in here. That will definitely be a complex root because you have 13, so no two numbers that multiply give you 13, but after -6, simply because 13 is a prime number, so it's only 13 and 1. You can definitely do a quadratic formula to find out what the solution to this thing is, but I actually opt for this, so that actually come out to be this. I opt for just doing the completing the square, which in this case pretty easy to do. So the lambda value come out to be 3 plus or minus 2i. So therefore, I'm going to say that lambda 1 is 3 plus 2i, and lambda 2 is 3 minus 2i. And now let's try to figure out what would be the corresponding eigenvector. So hopefully I have enough room here. That would be 5 minus 3 plus 2i, -4 to 1 minus 3 plus 2i, multiplied by uv equal to 0, 0. So let me see. So 5 minus 3 plus 2i is 5 minus 3, which is 2, and then minus 2i would be 2 plus 2 minus 2i, -4, 2, and then 1 minus 3 is -2, and then minus 2i. So one of the tricky things about having complex eigenvalue is that you will also end up with complex eigenvector, and sometimes it's hard to see what you need to multiply to actually get it to work. So here, if I'm looking at this correctly, it's easy for me to see what to do with the second equation. So I'm going to go and write out my second equation. And I can see that if I let u equal to 1 plus I, and so we let v equal to 1, I will have 2 times 1 plus I, which is 2 plus 2I plus negative 2 minus 2I, and that would give me 0. So therefore, tell me that vector u1 should be 1 plus I1. Now, some of you might be thinking, can I do something different? Yes, you can. And you will probably wonder with something look completely different than what I have. And when I say completely different than what I have, mean that you will feel like it's not multiple of what I have, which would imply that's wrong because all eigenvectors are multiple of each other. And I'm going to tell you the following. Yes, your eigenvector could look completely different than mine. It could definitely not look like it's a simple multiple of mine, but it would still be as long as you allow yourself to multiply by a complex number. That's usually the part that screw people over. Okay? Now, what do I mean by that? How about I show you a second vector u1 that you could use? In this case, if you instead using the top equation, what would happen to this one? Now, this one will be a little tricky. You can say that this one, I'm going to go ahead and use 1 plus I. Well, actually, maybe, yeah, I can do, actually, I'm going to do negative 1. Well, actually, maybe I do this one first. I'm going to go ahead and let u equal to 2. So then the first two things will multiply to 4 minus 4i. So here, if I do 1 minus I on this one, then I would now have 4 minus 4i plus negative 4 plus 4i. And that would actually cancel out to be 0. And therefore, meaning potentially, you can use vector u1 to be this. And if you look at this u1 compared to the u1 that I have on top, they don't look like they are multiple of each other. Okay? However, they are. If you take the top u1, vector u1, which is 1 plus I1, and multiply both top and bottom by 1 minus I, you will end up having 2 1 minus I. So it's very tricky because they don't look like they're multiple, but they are because of the fact that you have to use a complex coefficient to form their multiple, which is the part that is extremely tricky for most students to figure it out. Okay, so keep that in mind. Now I'm going to go and try to find u2. Okay, so I'm going to go for the same process. 5 minus 3 minus 2i, negative 4, 2, 1 minus 3 minus 2i, multiply by uv equal to 0, 0. Okay. So 5 minus 3 is 2, so it becomes 2 plus 2i, negative 4, 2, and then 1 minus 3 is negative 2, and negative is become plus 2, negative 2 plus 2i. So once again, this one I'm going to say easier to use the bottom equation because the bottom equation is 2u plus negative 2 plus 2i times v equal to 0. So once again, if I let v equal to 1, I can let u equal to negative 1 plus I. Oh, actually 1 plus 1 minus I. So that way we're balancing out. Okay, so it becomes 2 minus 2i plus negative 2 plus 2i. So 2 minus 2i. So therefore we cancel out to 0. There you go. So therefore, I'm going to say that my vector u2, in this case, is 1 minus I1. And once again, if you did not use the second equation, but use the top equation, you will get something that probably does not look like my vector u2, but it will still be a multiple of that. As well, maybe we just do it. Okay, I'm going to just do it. Oops. Just in case if that's what you do. So So again, I'm going to do the same exact trick. I'm going to go and multiply this by 2. So therefore become 4 plus 4i. And so this, I'm just going to do 4 plus 4i. So I'm going to do 1 plus I. Because then that will become 4 plus 4i plus negative 4 minus 4i. So that would give you 0. So therefore my vector u2 would actually equal to 2, 1 plus I. And if you multiply the vector that we got on the top by 1 plus I to top and bottom, that's what you're going to get, vector u2. So up to you which one you want to use. I'm just go with the 2 that I boxed in up here. Alright, so now let's see, we can do part B. Part B, let's say use u lambda t u inverse to find e to the ta. So this would be a little bit of work because we do have to kind of expand everything out, and we cannot use complex exponential. We have to write out into sine and cosine. So let's see if we can do this. So u for me would be, I'm going to use those that I boxed in. So 1 plus I1. And then 1 minus I1. Our lambda t would be e to the 3 plus 2it, 0, 0, e to the 3 minus 2it. And now u inverse, now this is a little tricky, so that would be 1 over 1 plus I times 1 minus 1 minus I, so minus 1 plus I. And then multiply by the matrix, so AD flip, so become D. These two negate, so negative B, oops. Negative C, and this is A. So if I look at this bottom right here, 1 minus 1 cancels, so it becomes just 1 over 2i. Nope, 1 over 2i, not 1 over 2 factorial. So, but I don't really like the I on the bottom. So what I'm going to do is, I'm going to go and multiply both top and bottom by I just to get rid of that. And if I do that correctly, there will be u inverse would equal to negative I over 2 times 1, negative 1 plus I, negative 1, 1 plus I. And yeah, because negative 1, because I times I on the bottom is negative 1, so therefore we have a negative. And I'm actually going to put the negative I inside just so that I don't have to deal with a complex coefficient in front. Easier to deal with just 1/2. And so that becomes negative I. Negative I times negative 1 plus I would be negative I times negative 1 become positive I. And negative I times I is negative I squared, which becomes plus 1. Negative I times negative 1 is positive I, and then negative I times 1 plus I would be negative I, and then minus I squared. So we can plus 1 again. Okay, so that's look okay. I'm going to just keep it that way. And so now I think I'm ready to go and try to find e to ta. So e to ta would equal to 1 plus I, 1 minus I, 1, 1, multiplied by e to 3 plus 2it, 0, 0, e to 3 minus 2it, multiplied by 1/2, negative I, I'm going to say 1 plus I instead of I plus 1, 1 minus I. So just a matter of multiply this whole thing out. So, oh, thank God we have another 15 minutes for this video. Otherwise, I don't know I finished this whole thing. Because there's a lot of multiplication here that we have to go through. All right, so let's I see no reason why we cannot just do it. So let's just do it. So therefore, that would be 1 plus I e to the 3 plus 2I t times negative 1 minus I times 0, which go away. Okay, and then this whole thing times this whole thing become 1 minus I e to the 3 minus 2I times t. And then this time this would just be e to 3 plus 2I times t. And then this time this would just be e to 3 minus 2I times t. Multiplied by 1/2. Negative I, 1 plus I, 1 minus I. So I'm going to go and pull the 1/2 out in the front. And just go ahead and let these two things multiply out and see what happens. So this time this would equal to negative I times 1 plus I become negative I plus negative I minus I squared. So become plus 1 e to the 3 plus 2I t plus 1 minus I times I become I minus I squared. So become I plus 1 e to the 3 minus 2I times t. That's the first term. 3 more to go. And when I do 1 plus I e to the 3I 3 plus 2I Alright, let's see if we can do the second term. So therefore, if I multiply this together, I will actually get look like 1 plus I square e to the 3 plus 2I t plus 1 minus I square e to the 3 minus 2I t. Alright, so we're going to try to figure out what that is in a little bit. Let's do this one. So this look like I'm going to have negative I e to the 3 plus 2I t plus I e to the 3 minus 2I t. And then this thing would multiply to 1 plus I e to the 3 plus 2I t plus 1 minus I, no square, e to the 3 minus 2I t. So that's what it looked like, and I have the 1/2 in front. So the tricky part is actually figure out what 1 plus I square and 1 minus I square are, and that's actually interesting. I'm going to go and try to do this right here. So 1 plus I square would actually come out to be 1 plus 2I plus I square, but I square is negative 1 and therefore cancel with the negative 1. And so this actually come out to be 2I. And you might be able to guess what this one come out to be, but it shouldn't be too hard to verify that's what it is. It becomes 1 minus 2I plus I square, which one is again the I square and the 1 cancel out. So that actually becomes negative 2I. So that look like I have simplified as much as I can. Except maybe I'll write this one as 1 minus I and this as 1 plus I. So I think that might be as much as I can do at this stage. So now what I need to do is try to clean up all of these complex exponential. So let's see what we can do. So that equal to 1/2. And I noticed that they all have e to the 3 plus 2i or e to the 3 minus 2i, which mean when I write in complex exponential, they all have e to the 3t. So I'm going to pull that out from all of them, so I don't have to keep writing them. After all, you know, mathematicians hate to write. And then what I have on this one is 1 minus I multiplied by cosine 2t plus I sine 2t plus 1 plus I multiplied by cosine 2t minus sine 2t. That's just the first term. This one right here would be 2i times cosine 2t plus I sine 2t minus 2i times, okay, you know what? Alright, you know what? I'm going to rewrite this and I'm just going to have to write smaller. Otherwise, I won't be able to fit everything. Alright, let's try this again. Alright, this will be 1 minus I cosine 2t plus I sine 2t plus 1 plus I times cosine 2t minus I sine 2t. Remember, it's minus because of the minus 2i. And this one will be 2i cosine 2t plus I sine 2t minus 2i times cosine 2t minus I sine 2t. Oh, there you go. Barely fit in. Let's just hope the bottom won't be as long. So this one come out to be negative I cosine 2t plus I sine 2t plus I cosine 2t minus I sine 2t. And yes, you're probably thinking like, holy God, that's very complicated. It's not, because eventually all of these come down to two terms. Cosine 2t and sine 2t. It's just a matter of working out the coefficient of all of them. Okay, so it might sound complicated right now, but it's actually not too bad once we get everything written out. All right, there you go. So let's see what happens if I do multiply all of these out. The tricky part about this multiply everything out is the following. There are essentially only two terms, cosine 2t and sine 2t. But they could have a complex or real coefficient in front. So that could potentially causes problem. So let's see if we can sort this out. So if I do multiply this top things out, notice a binomial times a binomial, so therefore we have to do FOIL. So that would be, and I definitely don't think I can write out this whole thing in one line. I'm going to have to write it in two lines. So I'm going to say this is cosine 2t plus, actually maybe I do it this way. Cosine 2t minus I cosine 2t. And then plus I sine 2t minus I square sine 2t. And minus I square is plus sine 2t. Plus, and I'm going to multiply this one on the second line, cosine 2t plus I cosine 2t minus I sine 2t minus I square sine 2t, we become plus sine 2t. So that's a complicated one. This one doesn't have a binomial, so that's pretty good. So this one would be 2i cosine 2t plus 2i squared, so become minus 2 sine 2t. Minus 2i cosine 2t and minus 2i squared, so become plus, no, actually no, it's minus 2i times negative I, so become plus 2i squared, so become minus 2 sine 2t. This one also not too bad. I'm going to distribute the negative I, so become negative I cosine 2t minus I squared, so become plus sine 2t plus I cosine 2t minus I squared. So become plus again sine 2t. And as you probably already noticed, some of these things are going to cancel out. That's like what usually happens if you do it right. So this is going to be cosine 2t plus I cosine 2t plus I sine 2t plus I squared, so become minus sine 2t. And then plus cosine 2t minus I cosine 2t, and then minus I sine 2t minus plus I squared, so it become minus sine 2t. All right, let's see what I can cancel out. So notice that I cosine 2t, I cosine 2t, I sine 2t, I sine 2t, those are gone. For this one right here, notice that the 2i cosine 2t are gone. For this one, the I cosine 2t are gone. For this one, I cosine 2t and I sine 2t are both gone. So that's not too bad because the remaining things can combine. So that actually cleaned up quite a lot now that I look at it. So because that becomes just 2 cosine 2t plus 2 sine 2t. And this one become minus 2 sine 2t minus another 2 sine 2t. So therefore become minus 4. I didn't expect that. And then this come out to be 2 sine 2t. And this come out to be 2 cosine 2t minus 2 sine 2t. And notice that all the coefficients are actually even. So I'm going to cross out the 1/2 with the 2, the 2, the 2, the 2, the 2. And then these 4 become a 2. And so I think we finally come down to our answers, which is our e to ta. So therefore, e to ta in this case equal to e to 3t multiplied by cosine 2t plus sine 2t, negative 2 sine 2t, sine 2t, and cosine 2t minus sine 2t. So that's my e to ta. Wow, it only take us like, I don't know, that long to figure out. Oh wait, no, B is not here. All right, so now come the last part, and that will be the last thing I'm going to show you in this video. Let's say we want to solve this. And let's say we have some kind of initial condition. Okay, then now what do you do? Well, so therefore a is just equal to e to ta multiplied by negative 2, 3. So therefore be e to 3t times cosine 2t plus sine 2t, negative 2 sine 2t, sine 2t, cosine 2t minus sine 2t, and then multiply by negative 2, 3. So therefore, we're just equal to e to 3t multiplied by negative 2 cosine 2t minus 2 sine 2t minus 6 sine 2t. And this multiplied by this become negative 2 sine 2t plus 3 cosine 2t minus 3 sine 2t. And remember, that's only 2 terms here, cosine 2t and sine 2t. We just have to clean it up. So therefore, if I look at this correctly, that come out to be negative 2 e to 3t cosine 2t minus 8 e to 3t sine 2t. And the bottom one come out to be 3 e to 3t cosine 2t. And then minus 2 minus 3 is minus 5. So minus 5 e to 3t sine 2t. So that's what our vector x is. All right, and I think that's it for today. All right, so we'll continue some more on the next video. All right, talk to you guys later. Bye bye.